In this video, we're going to look at 10-1 arcs and sectors, and this will look at specifically finding the arc length of a sector of a circle. So a central angle is the angle formed by two radii in the vertex at the center of the circle. So in the diagram, angle APB is 95 degrees, and then the central angle, that's the central angle, and then its arc is the arc AB. If I wanted to note a different arc in the circle, so notice that I could have an arc that goes this way, I would call that arc ACB, or I could do BCA. So in general, the order of the letters don't matter, in the sense that as long as I start and end with one of the points that start and ends the arc, then I'm noting the arc on its own. We just typically start with the most, the letters in as alphabetical of an order as possible. So I start with A, I go through C, then to B, is why I don't write this as ABC. So that's telling me which direction to go. ABC would be an arc that goes from A to B, then C. So see how that would be this arc if I wrote it as ABC instead. So the paying attention to the letters is important so that we know which direction we're going in order to know the appropriate answer. So we're going to be using the formula for arc length. S equals R times theta. So S represents arc length. And then we need to know the radius of the circle, but also we need to know the measure of the angle in radians. And so some of the problems will give us the measure of the angle in degrees, and we'll have to convert to start. So for example, 3A, we want to find the measure of arc AD. So remember that we have to be careful, and AD is the arc that just connects A and D together. So it's this arc here, not, for example, ABD or ACD would be that larger arc. And so what happens here is they're giving us all of the angles in the circle except for that angle that we need. And so what we want to think about is, what is the measure of angle APD? So theta is going to equal the measure of angle APD. And since we know all the other angles in the circle, we can find the measure of angle APD by subtracting all of those from 360. So since an entire circle is 360 degrees, we're going to subtract 73 plus 43 plus 104 degrees in order to identify the measure of angle APD. And so if we do that, we're doing 360 minus 220 degrees, which means that theta is 140 degrees. However, our formula S equals radius times the angle requires the angle to be in radians, so we have to multiply by a conversion factor to convert that to radians. So since I need 140 degrees in a radian measure, I want to reduce out my degrees. So I'm going to multiply by 180 degrees, by pi over 180 degrees in order to write our answer in radians, in order to use the formula that we have for arc length. So if I have 140 over 180 and I want to reduce, I can cancel out the degrees and reduce both by 10. These are both even numbers as well, so I can reduce by 2. So 14 divided by 2 is 7. So that's going to be 7 pi. And then 18 divided by 2 is 9. So 7 pi over 9 is going to be the value for theta. Looking at the diagram, the value for the radius is 4. So our arc length is going to be 4 times 7 pi over 9. And so I want to write this typically using the value for pi the same way that I would when I wrote the angle. And so in general, our answer should be, since 4 and 9 don't reduce, if I multiply 4 times 7, 28 pi over 9. And they don't give us a unit of measure for the radius, so we would just write units here. If for some reason they were asking you to divide that, you would plug that into your calculator, 28 times pi, and then just using the pi button instead of typing out 3.14, because it's more accurate, it gives you more decimal points, and then divide that by 9. That's about 9.76 units. So the arc length of arc AD is 28 pi over 9 units, or about 9.76 units. So in that example, we had a lot of work to do, really, because they didn't give us the angle that subtended the arc. And so we had to look for that value by subtracting for 360. For B, it's a little bit easier because they gave us the correct angle, and they actually gave it to us in the correct units. So since this is in radians, we don't have to convert anything. We know automatically theta is just 1.5. So because theta is a decimal, that also means that we can't write our answer in fraction form with a pi, because there's not going to be a pi in our value. We can also see from the diagram that r is 3 units. And so that means that our value for the arc length, which is r times theta, is 3 times 1.5. And so that means that the arc length for arc AB is 4.5 units. So much easier if they give it to you in radians and if they give you the appropriate angle. So remember, the key here is that you have to make sure that you're looking at the diagram appropriately and knowing how they name the arcs, but also checking to make sure that the angles that they're giving you are in radian measure as opposed to degree measure.